Hello everyone, my name is Ibrahim. Today we will talk about one of the hard problem, which number is 957. Our problem says that let the function z be defined by this equation, where phi is an arbitrary differential function and a, b, c are constants. We should show that this equation is true. We all know that this sign means partial derivatives, so we can start. Our first step is that find the derivative with respect to x, y, and z. It's a partial derivative, as I mentioned. In order to find the first derivative with respect to x, it's equal to 2x plus 2z multiplied by is differentiable with respect to x and this equation. We can apply same ideology for x, y, and z, and at the end we can find that phi derivative ax, b, and cz is equal to 4z divided by c. We will use it in the future steps. Second step is to find the partial derivative with respect to x and y. In order to plug, after that we will plug this value into this equation. So in order to find the derivatives with respect to x and y, we can use this function. For example, in first step we can find this. So basically I show that what I do, instead of this equation I plug 4z minus c and I have 4z minus c. After some simplifications we found that partial derivative with respect to x is equal to this equation. Same ideology we can apply to y as well. So in this second line, instead of this equation, we again write 4z divided by c. And if you look at the simplification, we get almost same result, where x and y and others are same. So our third step is the final step, replacing the values of partial derivative with respect to x and y. So it was our requirement to show that this equation is true. So we found the value of the partial derivative with respect to x and y, and we can plug these values. And if you look at, if we plug these values, we have the only values for example, if we simplify, you can see that we multiply line by line. And after many simplification, you can look at step by step here. You finally get x, y, c minus 2a, y, z minus x, y, c plus 2b, x, z divided by z. These values are gone, and if you divide every line with z, all z are gone, and plus a y minus bx. The final value is 2bx minus 2ay plus ay and minus bx. And after simplification, we got bx minus ay, which our statement says that we should prove that this equation equal to bx and ay. Taking everything into account, we simply we find the partial derivative with respect to x and y. How we can find? We find that our phi is equal to 4z minus c, and we plug all values in our statements. As a result, we got that really this equation is equal to bx minus ay. Thank you for your attention.